Hi everyone, my name is NURFADZIRA binti ABDUL. You can call me as Teacher Fazira. Today, we are going to learn impulse and impulsive force in 15 minutes. This topic is in chapter Force and Motion, so I hope you can lend your ears and focus for today's lesson. Okay. Before we start our lesson, let's look into the learning outcomes first. At the end of this lesson, students should be able to first communicate to explain impulse and impulsive force. 2. Solve problems involving impulse and impulsive force. Now, let's begin our lesson by getting to know what is impulse and what is impulsive force. First, we will be learning about impulse. What is meant by impulse? Have you heard before? Impulse is defined as the change of momentum. Do you still remember what we have learned before about momentum? Let's recall back together the definition of momentum. Momentum is the product of mass and velocity. In form of formula, we can write as P equal to m times v, where P is the momentum, m is the mass, v is the velocity. Okay, when we are talking about the change, it means it has the final velocity and also the initial velocity. Therefore, we can write impulse as impulse equal to m in bracket v minus u, where m is the mass, v is the final velocity, u is the initial velocity. The unit of impulse is kilogram meter per second, or we can write as Newton second. Why we can write as Newton second too? From the Newton's second law of motion, we know that F equal to ma, where F is the force, m is the mass, a is the acceleration. Now, let's replace a with its formula, which is a equal to v minus u divided by t. Then, the formula we get will be F equal to m times in bracket v minus u divided by t, where F is the force, m is the mass, v is the final velocity, u is the initial velocity, and t is the time. Let's bring the t to other side. Hence, the arrangement of the formula will be F times t equal to m times in bracket v minus u. Can you see m times in bracket v minus u is referring to the definition of impulse, just like what we have mentioned above. Thus, impulse can be represented as F times t, where F is the force, t is the time. That is the reason why we can write the unit of impulse as Newton second. Next, let's try to answer a question that is related to the impulse. A plasticine ball of mass 0.058 kg is thrown at a 10 meter per second and hits the wall. It sticks to the wall. What is the impulse of the plasticine? So, how do we solve this question? Step 1. List the given information in symbols. let's we look into the question and find all the given information. From this question, we have mass, we have initial velocity, and also from this question too, we know that the final velocity is equal to 0 meter per second. Why? As the plasticine ball is stick to the wall, it means the final velocity is equal to 0. So now we can list all the given information in symbol, which is mass equal to 0.058 kg, the initial velocity u, which is 10 meter per second, and the final velocity v, which is 0 meter per second. So step 2, identify and write down the formula used. Since the question is asking for impulse, we have to write the formula of impulse that we have learned just now, which is impulse F times T equal to M times in bracket V minus U, where F is the force, T is the time, M is the mass, V is the final velocity, and U is the initial velocity. So, the last step, which is step 3, substitute numerical values into the formula and perform the calculations. The answer we get after the calculation of the values is negative 0.58 Newton second. So, negative sign here tells us that the impulse is in the opposite direction to the velocity of the plasticine. So next, we will be learning about impulsive force. Do you know what is impulsive force? Impulsive force is the large force that acts over a short period of time during collisions and explosions. Impulsive force can also be defined as the rate of change of momentum. When talking about the rate, it means it is related to the time. Thus, the formula of impulsive force can be written as impulsive force F equal to mv minus mu divided by t, where mv is the final momentum, mu is the initial momentum, and t is the time of impact. Now, let's see and try to do a question that is related to the impulsive force. A golfer hits a golf ball of mass 45.93 grams at a 50 meter per second. If the impact time is 0.005 seconds, what is the impulsive force acting on the golf ball? So, the solution of this question will have the same steps like what we have done before for impulse. Step 1. List the given information in the symbols. Let's we look into the question and find all the given information. From this question, we have mass, we have final velocity, and also we have the time of impact. Now, we can list all the given information, which is mass equal to 45.93 grams. Please remember to write your physical quantity in the SI unit. That is why we change the unit of gram to kilogram. The initial velocity u is 0 meter per second. The final velocity, which is 50 meter per second, and the time of impact is 0.005 seconds. Step 2. Identify and write down the formula used. Since the question is asking for impulsive force, we have to write the formula of impulsive force that we have learned just now, which is impulsive force F equal to mv minus mu divided by t. The next step, which is step 3, is substitute numerical values into the formula and perform the calculations. The answer we get after the calculation is impulsive force equal to 459.3 Newton. From the answer, we can say that the impulsive force is acting in the same direction as the velocity of the golf ball. So next, we will see a situation where impulsive force is beneficial. The example of this situation is a mortar and a pestle. Do you know what is a mortar and what is a pestle? A mortar and a pestle are made of hard rock. Now, let we watch the video together. The relationship between action on mortar and also the reaction on pestle can be explained in Newton's third law of motion. Newton's third law of motion states that for every action, there is a reaction of equal magnitude but in the opposite direction. So here's some explanation regarding to the video. A pestle moved at high velocity is stopped by a hard mortar in a short interval of time. A large impulsive force is produced. This statement can be proved by the formula of impulsive force, which is impulsive force F equal to mv minus mu divided by t. From this formula, we can see that the impulsive force is inversely proportional to time. Therefore, if the time of impact is shorter, a larger impulsive force will be produced. The last part for today's lesson is a situation where impulsive force should be reduced. One example which is very familiar to our life is a high jumper lands on a mattress. Now, let's rewatch the video below together. During a high jumper will land on a thick, soft mattress after the jump. This is to increase the reaction time and hence reduces the impulsive force acting on the high jumper. This can also be seen through the formula of impulsive force, which is impulsive force F equal to mv minus mu divided by t. As we know, the impulsive force is inversely proportional to time. Therefore, if the time of impact is longer, the impulsive force will be reduced. So we can conclude that a longer time of impact will result in a smaller impulsive force, and a shorter time of impact will produce a larger impulsive force. So that's all for today's lesson. I hope you will get something benefit from this video. Thank you for lending me your ears and have a nice day, everyone. Thank you.